Good morning. My name is Taco Law. Is the mic all good?
Yes, ma'am.
Okay, cool. Good morning. My name is Taco Law. I work as the Operations Manager Oceania for ISC Technologies, along with David Crossman here, who is our Managing Director Oceania, and we'll be delivering a presentation about the use of freeware to support regional capability development. Our presentation will cover a number of different projects where free and open source solutions have been essential to their success. The first is NAVIC, and then UMAP, and then we'll talk about some training and education and New EIMS, and then we'll have time at the end for any questions. To give you guys some background about ISC Technologies, we are a global company originally established in 1993. We have a team of around 1,200 and have offices in 4 continents. We call ourselves a full service end-to-end geospatial company, from data acquisition all the way to chart and product production. We also have an innovation center that carries out research and development, and ISC Academy, which delivers education and training. We support over 75 national authorities around the world, and this slide shows some of our clients in Oceania, and the ones that are listed in blue are clients that we currently have active contracts with. I'll now pass over to David to speak about NAVIC and UMAP.
Thanks everyone, it's a real pleasure to be here. We have a small but high quality audience on the left hand side for some reason, but we'll try and tailor this as best we can. The first thing I want to say is this isn't a marketing spiel. Yes, we are a commercial company, but we're contracted to provide tools and support and services, and wherever we can, we build free and open source software into our resolves, particularly when we're delivering on behalf of, say, World Bank or Asia Development Bank to the Pacific Island nations. So Taka and I have got a real passion for the Pacific Island, and they don't have the resources that, say, New Zealanders or other big countries have. So where we can, we try and provide them with resolves that will mean that they can use them with longevity well beyond the time of the contract delivery, okay? So we're going to talk to 4 different areas, and we're going to do it pretty quickly. So the first one is NAVIC. So NAVIC is a free electronic chart system. So similar to what you'll see in small boats. And there's some really unique things about this. Now, you won't often get this in a presentation, but feel free to download the app while we talk, and if I'm boring you, just crack on and have a play with it. But what's amazing about the tool is that everything lives in the cloud. So it's a minimal interface on your smart device. So it's not putting heavy burden with data or the technology on the smart device itself. It's also a really clever tool. So we are specialists in provision of maritime data to national authorities. So this isn't an IMO qualifying ECTA system, but it actually has really high functionality with lots of different layers and lots of different tools that you won't get in your normal paid for ECS systems. So what's it got? It was released in February 2023. As I mentioned, it's a freely downloadable app. It's cloud-based. What's really important about this is we actually use National Authority S57 data. So the Hydrographic National Authority for your nation, so for us it's Land Information New Zealand, or it might be NOAA, or it might be UKHO. The data that they release for the big ships to use for paper charts and ENCs, this is what you get in this system for free. And we also include the fortnightly updates that are produced, so they automatically get pushed out. So this is as good as what your commercial ships are using, but it's for free. We see it as a tool that can be used by fishermen, small boaties, but it can also be for kayakers, stand-up paddleboarders, and all those people that everyone carries a smart device, but they may not have the funds or the desire to carry the big electronic chart technology. We've built into it numerous layers for the land and the sea, and it includes things like real-time tides and current information. It has route planning and route guidance, so real-time route guidance. It has real-time positioning, and it's got built-in emergency functionality. So if you get bored of your friend and push them over the side, you can then hit man overboard, and it'll give you a range and bearing back to that person. It also has built-in communication, so you can take a photo of your big fish and send it to your mate, or your community of mates, or more importantly for the smaller island nations that don't have big maritime safety capabilities, you can tell your Maritime Safety Authority where you are. So real time they can watch 20, 30, 40 small boat and local fishermen out there doing their thing. So coverage at the moment, we've got USA and all of the American dependencies globally. We've got New Zealand and the New Zealand charting responsibility areas, so Tonga, Samoa, Niue, and a number of international charts. We can do this for anywhere in the world, but we'll only do it with National Authority S57 data, which is completely protected, but we don't want to degrade our system with non-National Authority data, so at the moment we've limited it to those. So if your nation isn't on that list and you're interested, let's have a chat and we can work with your National Authority to get it up and usable. Benefits: improve safety of navigation everywhere, but in particular areas such as the Pacific Island nations. It's at no cost for the user. It uses official data, it's the only one that does, and it's kept live with real-time updates, and it's a great tool to support maritime safety authorities. And it's about to have a major uplift, so we're going to rebrand it, we're going to make it more user-friendly, we're going to have AI integration, and I dropped a pin yesterday, and that's where we are, just to prove that it works even inside the building. Next one, UMAP. So UMAP is a QGIS plugin that was built by IIC for the Canadian Hydrographic Service. Now, CHS, like many national authorities, have areas of charting responsibility well beyond their means. So 23% of Canada's waters between 0 and 200 metres are surveyed, only 23%, but 66% of that 23% is actually out of date. It's no good. More concerningly, 90% of Canada's waters between 0 and 100 metres are completely uncharted. And it's worse when you look up in the Arctic area where the indigenous Aboriginal communities or the Inuit communities live. So you can see this little island, this little community here, they got nothing, right? Now the problem for these communities is that they're heavily reliant on those coastal waters because they need it for their fishing and their marine resources, they need it for the logistics support that comes in, but they also use it as transport nodes. So rather than going over land, they use the inshore routes to get from A to B between villages. And they stay close to the coast because that's more sheltered, so they're in areas that are not surveyed and most likely to have dangers. The problem is the area is so vast that it's completely beyond the CHS to be able to provide them with good charting. So they created the Community Hydrographic Program. They identified 3 key areas. First was data gathering, next was processing, and the final one was cartographic representation. Each of those 3 areas are massive, expensive, take time and specialist resource, so unrealistic to expect from the local communities. So they came up with a 3-point plan. The first was data gathering. So they provided training, specialist bathymetric data gathering tools, or all-in-one plug-and-play bathymetric data gathering tools, or data loggers that would plug into their existing fish finder. In fact, they gave them lots of fish finders. So the communities got really excited. They went out and started gathering data. The data wasn't clean, so CHS created a small cell. The communities would gather the data, send it to that CHS cell, they'll do a quick processing, send it back to the community. There was their data, beautiful. No way of visualising it. So they got bored, it fell off. If you can't use the data, what's the point? So they said, well, we need to crack them up for the cartographic representation. So what they did was they did a speed mapping challenge in 2022, which IIC won, and they commissioned us then to build that into UMAP, which is a QGIS plugin, which I'll talk about now. So it's built by ourselves for CHS. All you need is a shoreline and bathymetric data, so either DTM or XYZ data. Topo contours are optional, chart limits are user defined, and everything else is done by the system. So the outputs is that it will do the vertical adjustment, it does the deconfliction of shallowest against deepest of multiple data sets, and then the system will automatically do the International Hydrographic Organisation specification charting analysis, okay? To prove it, they commissioned an independent study, so a team of people went out for 18 days, took satellite derived bathymetry and gathered data, so they had 300 kilometres of multi-beam data. On the 18th day, they dropped it into UMAP, and within minutes, they had a chart-like product. So this is happening. Open QGIS, zoom into your area of interest, open UMAP, upload your coastline. In this case, they're going to drag and drop. Then you select your scale, then select your shoreline, which they're doing there, then select satellite derived bathymetry and the bathymetric data, hit go. And this is doing it. So all of that vast amount of effort, vast amount of work that national authorities pay people like us to do, or they have themselves, is done as quick as this. And what you'll see is the area where there's no data is grey, the areas that are drying are green, and then in the area where we've actually got satellite derived bathymetry or XYZ data, there's actually a sounding selection that conforms to the IHO requirements. So you've got deconflicted soundings, you've got sounding selection, you've got IHO contouring, and ugly colours. Now the reason for the ugly colours is that it's built by CHS. They're the National Charting Authority. They can't afford the liability of someone saying, well, we did it with a CHS chart. It's not a CHS chart, it's a map. And it's even released in QGIS as an IIC technology resolve so that it's independent of CHS. However, as I said, it conforms to all of the requirements. So outcome, commissioned by CHS, built by us, not an official chart, but gives you actually a chart-like resolve. Ugly colours, but you can change them to look like standard IHO chart colours if you want. Support safety of navigation, encourages the communities to work. The communities love it, so they're out there gathering the data and they're using it for themselves in their own ECS systems. And it can be used anywhere in the world. CHS said make it global, so anyone can use it in your Pacific Island, Tonga, wherever you want. You can go up there, gather data, drop it in, and away you go. And it encourages citizen science. So that's UMAP. There's a link to the UMAP plugin. There's a link to the demo there, and there's a really good article written by those people that did that pilot study. Tak.
Perfect. So I'm going to talk about some training and education used for capacity building. So ISC undertakes bespoke and internationally recognized training through our academy, and I'd like to highlight a couple of areas where we utilize open source software and freeware for the benefit of our clients and the region. So the first training activity I'd like to speak about is the SPC LiDAR data training that we carried out. It was originally intended to be delivered to a group of 48, but we ended up delivering it to 90 plus students from 10 different countries, including SPC. The training covered foundational information such as geodesy, datums, water levels, quality, LiDAR, and geospatial, other geospatial data, GIS, data management, and data manipulation. We focused on using only freeware for this training, and particularly QGIS, to make it accessible to all of the students to utilize in their country and be able to benefit long-term from the training without access to software being a limiting factor to their continued capability development. This training was very successful and led to a development project in Niue, which I'll talk about soon. The next training activity that I'd like to talk about is the S5B Hydrographic Surveying Program and the S8B Marine Geospatial Information Program, both taking about 8 months to complete. For both of these programs, we use free and open source software wherever we can, as a lot of students don't have access to more expensive specialized software, and some students work with companies that use different software to what we use in our regular operations. So we've made it as accessible as possible for students to use open source software solutions such as QGIS, Natural Resources Canada's precise point positioning tools, AusPOS GPS processing, and more. So both programs can be delivered as a bespoke or as a standard program and are completed as self-paced learning, and we have students who balance their full-time work as well as studying the program. And for both of these programs, there's obviously practical hands-on components that need to be completed. So we have in-person practicals, a 4-week practical for the S8 course and an 8-week practical for the S5B course. And in this region in particular of interest, as part of a survey project that we carried out for the government of Kiribati, we provided positions on both the S5 and S8B program to help build their hydrographic surveying and marine GIS capability. These programs are the only IBSC approved online distance learning programs for hydrographic surveying and also marine geospatial information. And both of these programs are now running annually. There's a QR code there if you guys are interested, or if you have any questions after, feel free to ask anything that you have. Come on. So the next thing that I'd like to talk about is the electronic information management system project that we worked on for Niue that came from that SPC LiDAR data gathering training that I mentioned earlier. So we're active supporters and users of open source technology, and many of the solutions that we develop benefit greatly from the work of the open source community, and an example of this is the Niue EIMS project. Niue participated in that LiDAR data training that I mentioned, and on completion of the training, the Niue government approached us with their concern as they have fantastic LiDAR data that's provided by SPC, but they have no ability to utilize that data due to a lack of infrastructure. And we discussed the situation with Niue and found that they have disparate data, minimal data that is held locally, and data sharing within their government is very limited. So as a result, they have a very limited ability to benefit from the data that they hold. Having discussed the situation with the Niue government, we created a proposal for a resolve that we now call the EIMS, the Environmental Information Management System. We had 24 stakeholder meetings that were held, including with the Niue government departments, wider communities, and NGOs. And in the meetings, we explained the concept and discussed with them their user cases and scenarios. And from this information, we created a prioritized list of user requirements, and you'll see that on the table there with the blue header. And this led to some standard user requirements that you'd expect, such as a spatial data infrastructure, but also led to some unique requirements such as a village portal, community messaging, and educational support. After reviewing the requirements, we came to what we call a silver bullet resolve for the data and information management, a SDI+++, to have, hold, build, manage, serve, analyze, share, visualize, report, spatial and non-spatially enabled data, from images to video, sound, art, history, and even medical information as well. So the solution was creating a web application to manage and visualize the spatial data, and a mobile application in which these spatial services could be consumed. So we've used the latest and greatest open source technology and software to build the solution, and here's the stack that we used. For the Niue EIMS project, we used a portfolio of high quality open source components spanning the back end as well as the front end development. We used Postgres database, GeoServer, Tomcat as web server, packaged in containers using Docker technology. And for the front end, our main components that we used for geospatial data visualization was OpenLayers, although more recently we've used Terra.js, and that was a component used for this specific development, as well as HTML5, CSS3, JavaScript, jQuery, and Bootstrap. And for the backend, we predominantly developed using Java and JavaScript technology, and we use Spring Boot framework combined with Open API specification, and we use Swagger to document our API endpoints. Utilizing open source resources really helped us to bring a robust and cost-effective solution to the client. So once you've logged into the web service, this is what you'll see. The system is fully up and running, but we aren't able to provide a live demo as the client has requested to shift from a cloud to a physical infrastructure, which is an ongoing process currently. So as a result of what we've delivered, we've provided an easy-to-use portal for them that's web and also smart device capable, with managed user access and the access to the full Niue data holdings, and also direct or grouped access and links to other relevant data holdings as well. So in summary, we've achieved all of the contracted and intended outcomes and have provided Niue with an STI integrated with a knowledge base containing all of the functionality and features that you can see here. And some additional outcomes as well. As a result of this process, IC have been able to engage with off-island organizations and entities on behalf of the Niue government and have collected and collated Niue data using the EIMS, resulting in an increase of Niue's data holdings by 400%. And another outcome that we're very proud of is that UNESCO has listed the Niuean language as definitely being at risk of being lost. And however, because the EIMS has an embedded knowledge base that can hold the information on Niue culture, history, language, and traditional environmental practices, this system will help preserve the Niue culture and language for future generations, which we believe is an incredible byproduct of a spatial data infrastructure. So I'll now hand it back to David to close the presentation.
All right, thanks very much. That's all we wanted to talk to. We hope that was useful and interesting and shows how free and open source software can be used beyond just a contract environment to provide sustainable long-term benefit to your on-flow clients. Does anyone have any questions on any of the things we spoke about here? Just to say, Tark and I aren't technical specialists. We're hydrographic specialists, so we can talk to a certain level, but we certainly can't talk programming or scripting. Yeah.
So that was really interesting. I think I tried the UMAP plugin about a year ago, and I had some issues with it, and I gave up, I'm afraid. But it couldn't seem to cope with stuff near the 180 line. I think it was forcing you to use WGS 84, and if you had stuff near the time, we were doing it for an example for Fiji, and it struggled. So I wondered if there'd been any more development in the last year, and if I should.
I'll give you my card afterwards. We'll have a look if that's an area that's not been identified. I'll be able to look at it. I mean, we deal with Meridian stuff all the time, so it's surprising they haven't picked that up.
And to be honest, I haven't looked for a year, so maybe I should have just
played more. I'd forgotten about it till I saw
and
this.
the primary client obviously doesn't have to deal with that, so they may have overlooked it, but thank you for picking it up. I'll send a message out to the team and make sure they take it into account.
Thanks.
Difficult, isn't it?
I was wondering if you have any feedback from your cartography courses when trainees want to use open source software. Is it a problem, or is it easy for the trainers and the trainees to use?
For the most part, it's relatively simple, but that's because we generally give them step-by-step guides, and we're leading them to the open source software that we're wanting them to look at. And we don't have any preferences, we don't favour anyone, we just use whatever tool is best for the task. QGIS we use a lot, we'll often set up. So where we know we're going into a country where they may not have good physical infrastructure, we will set up virtual machines and preload everything on. But we'll still give them step-by-step guides, because what we want to do is when we leave, allow them to carry on doing it over and over and over. Step-by-step guides and video tutorials are the best way to go. So we've had no feedback on there being any complications, but that might be because we pre-position.
All right.
There's a
One more
question.
question. Yeah.
Last one. I don't know. Sorry, I know this. Your presence in the your presence in this side of the globe with IIC, your clientele have any churches or faith-based organizations approached you for your assistance in using or to use to assist their communities, sort of thing?
No, they haven't, but we'd be very interested. Some nations, you know, the religious side is absolutely ingrained within the culture anyway. So for the likes of Niue, what we would expect is as they develop the community engagement piece, they would build that into it. But no, it'd be very interesting to talk further about that. Sort of stuff.
Probably just part of the challenge with Niue might have. I don't speak on behalf of Niue, by the way, but for our side, because we're all culturally linked in some way, we tend to take things off the cloud, and makes it hard for programmers and software developers. But for us, because the church factor actually is more effective on groundwork. We come from grassroots levels, by the way. And our governments usually, after your conferences, after you equip them, it stays up there, it never filters down to the rest of the country. So probably it's nothing against you that you it was just the way things are. Yeah.
So I'll make a
But
comment.
thank you, though.
The recent changes in costing model for cloud-based results has made it completely cost prohibitive for small nation islands. So that's the only reason they're moving it off the cloud. It's not, they cannot do it now. So they have to do it in this construction. You're over time. David, chat to you after.
Great questions, everyone. Thank you to our speakers. Thanks so much.